Hello. This video will do a quick review of what we discussed in class about quadratic graph and their properties. First of all, I need to emphasize that the question that a lot of people ask and make mistake in class is, what is the standard form of a quadratic function? We know that the term quadratic suggests that the highest degree of the polynomial is 2. Okay, and the standard form for this quadratic function is y equal to ax squared plus bx plus c, and with the condition is a have to be different from 0. Okay, the reason why a has to be different from 0 is because if this is equal to 0, the function becomes y equal to bx plus c, and it becomes a linear function. Okay, function with the highest degree is 1. Now we're talking about the quadratic function. That means the function with the highest degree is 2. Now I emphasize that you need to actually understand what the a, b, and c mean. And a, b, and c are the coefficients of the function, and the way to actually distinguish a, b, and c is that a is in front of x squared, b is a number in front of x, and c is a constant. Okay, so let's look at some examples. Example, we have y equal to 3x squared. Okay, in this case we assume that so here a is 3, right, because 3 is in front of x squared here. Now what about b and c? Okay, what about b and c? Now b and c we don't see here, right? So it means that 0. So we can write is 0 times x plus 0. Okay, so b here is 0 and c is also 0. Now this is very important because later on in this chapter we will have to identify the a, b, c of the quadratic functions in order to draw a graph, and then also to calculate and find and solve quadratic equations. So let's try another example. We have y equal to x squared plus 9. Okay, so in this case my a here is, okay, a is the coefficient, the number in front of x squared, and here we know that this is 1. Okay, and because this is 1, we don't write it out. B, again, we don't see bx here, so it will be 0. And c the constant, okay, the number with the variable x, so c is 9. Let's try another example. Y equal to x squared minus x minus 2. So here a is 1, b is the number in front of x, which is equal to -1, and c is -1 and -2. Sorry. Now, a lot of people actually write 1 and 2 here without the minus sign, and this is not correct. You have to account for the sign of the coefficient as well. Okay, so here's -1, here is -2. So remember that. Now the question is, what is the simplest quadratic function? Okay, and the simplest quadratic function, the simplest quadratic function is actually when a equal to 1 and b and c equal to 0. So that means f of x equal to x squared. Okay, when a equal to 1, b and c equal to 0. And this we call it a quadratic parent function. Quadratic parent function. Okay, and I will talk about the reason why in a second. But here we know that the shape, okay, the graph of this function is actually a parabola. So in this chapter you also have to be able to graph these functions. So the first one is that we have OX and OY here. Okay, the graph of the function is actually a parabola. Okay, so the graph of a quadratic function, first of all, it has a U shape. Okay, and actually the term for it is a parabola. The second characteristic is that most of you are familiar with this graph, right? Let me try to Alright. So most of you have seen this graph before. So it's U-shaped, but the interesting thing here is that it can actually, if you fold the parabola at the y-axis, so the two half of this graph here actually will match together. Okay, exactly. And what it means is that the parabola is symmetric about the x-axis, the y-axis. Sorry, the y-axis. Okay. So symmetric. Okay, symmetric. If you fold a parabola, the two sides, this side and this side, will match exactly. Okay, and this is the lowest point here, right? So the graph from left to right decreases a little bit here, and from left to right decrease up to 0, but then from 0 to so here is negative infinity, right? Negative sign here. From negative infinity to 0, the graph decreases, and then from 0 to positive infinity, the graph increases. Okay, what it means is that actually we talk about the domain. Okay, domain of the function, and domain of the function is that because all values of x, okay, so no matter how x approach to negative infinity to positive infinity, we all have a value of y. Okay, So it means that the domain of this function, y equal to x squared here, is all real number. Okay, all real numbers. Another way of writing this is x belong to the R. Okay. Now, how about the range? Range, collection of the values of y. Remember that we see that as x approach to negative infinity, right? As x move to negative numbers here, we see that the y actually go this side, this way. All right, keep going up, and when x approach to positive infinity, the graph also move up. Okay, approach to this side. So the y here is actually the y moving the upward directions. Okay, how about the limit? Here is actually it takes the value of 0 and move up. Okay, so the range here, y is greater or equal to 0. Okay, it does not go below 0. The y values of this function does not go below 0. Okay, so what can we say about this? Now, what we can say is that the highest or lowest points, of a parabola is its vertex. Okay, is its vertex. Okay, and the vertex here is also on this vertex is also on the axis of symmetry. The axis of symmetry. So for example, in this case, the lowest point of this graph, y equal to x squared, is actually 0. Okay, so this is the vertex. Vertex 0, 0. Okay, so this is the vertex of this function. And how do we find the symmetry? Actually, it all depends on the A. Recall that we have the standard form of the quadratic function is y equal to ax squared plus bx plus c with a different from 0. Now, when a is positive, that means a greater than 0, the parabola opens upward, right? The parabola opens upward. Okay. Another word for this is concave. So it's concave up. Okay. Open upward like this. Okay, so this one. So A is 1, which is positive, so it's open upward, concave up. Now, when it's open upward here, okay, because of it open upward here, it has a vertex, right? But this is the vertex here. In this case, is the lowest point. Okay, so the vertex is the minimum point. The minimum point. Okay, minimum point or the lowest point.